I'm competing with two toolbars. There we go. So just as a sort of a reminder of how we got here, the HERS index was created in 1995, and it really, at the time, was the HERS score. And the HERS score, higher was better under that system. And then that worked from 1995 to 2006. And then in 2006, they shifted to the HERS index, where lower is better. And prior to that, they'd been referencing the 1993 Model Energy Code. And then in 2006, they shifted to referencing the 2004 Supplemental Energy Code, which was not a published code. It was just a supplement. And that worked from 2006 to 2012. And 2012 to about 2014, we shifted quite a bit. We made the shift from the 2004 code to the 2006, the published code. And then in 2014 to 2016, we were operating under the ANSI RESNET ICC Standard 301-2014. And that was a real push for us. You know, we became an ANSI Standards development organization, and we produced it took us 2 years to produce that first standard. And then we republished it in 2016 with some amendments that had taken place between 2014 and 2016. And then, you know, that's the published version that is referenced in the 2018 code. And then from 2019 to the present, we're under ANSI RESNET ICC 301-2019. Now, the 2014 side, we were making a big push to get that standards development finished in time for the 2015 IECC code publication so that we could be incorporated into the code. And I was under a lot of super intense pressure to make that happen, but I wanted to get it right. And so we put the brakes on some things just so that we could make it as good as we could get it. And we missed our publication date by 2 weeks. And so we didn't make it into the code to be referenced in the code. So the 2015 IECC is where the ERI first came in. And, you know, it's in R406. And when that happened, they didn't have any reference standard to point to. And so there's some really loosey-goosey language in there. They're mixing energy loads and energy use, which are two wildly different things. In fact, the way it's written, the HERS index didn't even comply with it. And so that created a lot of problems for me personally, because, you know, it was just a really poorly written. And I was at the final action hearings in Atlantic City, and that was the first time I was getting to see the language. And it was like, this was, I felt bad. Then in the 2018 IECC, they actually referenced the second edition, which was published in 2016, which I chaired that committee at that time. And then the 2021 IECC references 301-2019, which is produced under my successor, Gayatri Vijaya Kumar. She's a really super brilliant mechanical engineer. So that's kind of like how we got here. And then these two competing index things are kind of crazy. Like, you know, what do they do? Because there's a lot of confusion about that. And a lot of the confusion starts when RESNET puts out videos that says, you know, it's like a miles per gallon sticker for your house. And it's really nothing like that. It's kind of crazy, but it calculates the ratio of energy loads between the house as it's built and the reference design. And that's all based on the calculations that are found in the ANSI standard. But there's absolutely no correlation between that index number and energy consumption. And there's no correlation between that index number and the costs. And so, you know, if a guy says, well, my house is, got a HERS index of 50, so it's 50% more energy efficient than the code home, well, maybe. It's not going to cost 50% less to operate. It's not going to use 50% less energy, because energy loads don't use energy, but they cause energy to be used. And this has led to quite a bit of issues in the the energy ratings industry, because none of the software developers can agree on what those loads actually are. What elements in the building actually cause those loads. So that's always been a thing, and probably something for a future discussion. And one other thing that they had to do was they had to dumb gas appliances down to equal that the efficiency of electric appliances because of the so-called fuel wars. And I got accused one time of trying to reignite the fuel wars, and which was funny because all I did was I let a guy from National Renewable Energy Labs do a presentation at one of my committee meetings. And, the fuel wars, the gas versus the electric versus gas, I've talked to groups on both sides, and it's really a moot point these days, but we still dumb the gas appliances down to create this level playing field. And then we also make a lot of assumptions about the home in there. So basically, when the energy raters are out there doing their work, and by the way, the work that they do is absolutely necessary. So I don't want anybody to get the wrong impression. But when the energy raters are out there doing their work, they're collecting about 250 data points on that house. And that goes into the software. And then the software puts it through a translation layer where those 250 data inputs are turned into about 10,000 inputs into the calculation engine, which then does all the crunches, all the numbers, and spits out the actual index number. So there's a lot of assumptions that are happening behind the scenes that most people are unaware of. So just to be perfectly clear with everybody, the HERS index and the energy rating index are all about energy loads, not energy consumption, not energy use, and not energy cost. The energy consumption, energy cost falls under the performance path in the code, which is found in R405. So what's the difference between the HERS index and the energy rating index? Big differences. The reference design is huge. So the HERS index references the 2006 IECC, but the energy rating index modifies the building envelope for the reference design. In the 2015 IECC, they referenced the 2009, same in the 2018. In the 2021, they referenced the 2015 minimum requirements, sort of. Ventilation, there are differences between how ventilation gets calculated, because again, in the code, there is language in the code that says you have to follow this calculation, not the calculation that's found in ANSI 301. And the frequency with the updates, the code references the published version that was published at the time when the code gets put through, whereas in the RESNET side, in the HERS index, in the proprietary system, there is a constant, it's under continuous maintenance, so there's constant updates that are going in, modifying those calculations on, about every 3 to 4 months, the calculations are getting modified. And what happens then is you end up with differences in index values. And so here's one of the things that you should probably pay attention to. And you guys can read that. So when you're done reading it, Jason, if you could just give me a signal, and I'll use you as the benchmark.
Yeah, that's kind of what we see, huh? I'm done.
Okay. Well, I assume everybody else reads as fast or possibly as slow as Jason. No. So I pulled together some reports. So I randomly selected some houses to show you guys what that means, right? Because if code officials are accepting the HERS index as an energy rating index for code compliance, they can be wildly wrong. So this is the actual same house, identical house. I mean, this is the house. This is the report. And you can see on the HERS, the home energy rating certificate, the HERS index score was a 54. And if you look over on the 2018 code compliance report for the energy rating index, you can see that it says the maximum energy rating index for code compliance would be 57. This house scored a 61. But if you were using the HERS index and not the ERI, you'd say, oh, this house complies with code, even though it didn't. And one of the big challenges is the HERS index is just a measurement system. It's just an index, and there's no compliance requirements for the mandatory requirements in the code at all. There is no pass fail on the HERS index. You can have The worst I've seen personally was a HERS index of 310. That was a rental house that I lived in that had been built in the 1930s. And I've worked on projects where we've gotten houses that were a negative 45 because of all the PV that they added. They literally built a bigger porch roof so that they could have more PV so they could get a really low number. And so all of that comes into play. And if code officials accept the HERS index as an equivalent energy rating index, we run into some serious problems.
I'm
Particularly
missing something here because this is, I'm looking, okay, it's an Ecotrope report, and this is from the 2018 where, and I understand what the title of this presentation is and where we're eventually going and what we're going to learn, but I evidently was mistaken. Without PV on here, I thought ERI and HERS would be the same, and I'm clearly wrong. Anyway, obviously you're about to tell us, so I apologize. Go ahead.
Yeah, because it's, we'll get into actually why that all happens. So then I took one house that was rated by one rater, and I bounced that house in the software to all these different locations in Texas. And so that we could see the difference, the index variations between the HERS index and the energy rating index. And this house, by the way, is the most tested house in Texas. It's been tested about 300 times, roughly. It's my personal home. So we're confident in the data, unlike a lot of other ratings that you may run across. We're confident in this data. But this is what happens when we bounce that house around Texas. So when you get done reading the table, Jason, just let me know.
Yeah, and we did a deal. I mean, you've read, I'm sure, at least read the synopsis, that DOE variability report we've done, but this obviously is totally different. This is one house just placed in different locations. Did you use Ecotrope for all of it?
Yeah.
Okay.
And Ecotrope, which, in full disclosure, they're a past client of mine. I helped them, our marketing brand did a bunch of research for them, and we helped them get to, where they are, which is roughly 60% market share in the energy rating software side of things. They use a proprietary calculation engine. I did a bunch of research, and I've got some white papers that we've written on the differences between the different software tools from Energy Gauge. We ran comparisons between Energy Gauge, REM Rate, Ecotrope, and now there's, of course, more software tools coming onto the market that use Energy Plus, which is produced by the Department of Energy. And again, that's an entirely different probably presentation to get into as to how these variations happen. But just this one house getting bounced around, you can see, it ranges from 5 to 7, but it's mostly 6 points difference between the HERS index and the energy rating index, and the HERS index is always lower. And it seems, when we look at the data, it seems as if RESNET is pushing they're producing their calculations on their proprietary system so that their HERS index will always be lower than the energy rating index. I've never seen the HERS index higher than energy rating index. It's always lower. And every time we get a new version of the software, the HERS index seems to drop just a little bit more. And so we can track that, and we have tracked that over time. So RESNET markets itself as, the HERS index is the gold standard. It's the one that all the builders are using. The energy rating index turned out to be a competitor of theirs that they produced, and it was cannibalizing their own, revenue stream, which it makes sense that they'd want to do this, but it also doesn't make sense. From a building science perspective, you would think that everything should line up, but it doesn't.
Well, like I said on that project we did, it won't even line up on the same house just because of, well, and I did read that article that you wrote about is that good data? That was a good article, by the way.
Yeah, well, there's a future presentation there for you.
Okay.
So this was actually what we did in this table. I pulled different raters in different climate zones, just one of their houses around the country. So you can see that this isn't just something that happens in Texas. Again, you can see in this particular situation where we're not looking at one house, we're looking at different houses. In El Paso, they get a 7-point variation. In Corpus Christi, that particular house was a 6-point. Fair Oaks Ranch, they got an 8-point difference. Auburn, Alabama, this is actually for the university there, a project that they were working on. They got a 5-point difference. Out by Nashville and Brentwood, they got a 9-point difference. And one of our PhD mechanical engineer clients, that's an energy rater, up in Aberdeen, Maryland, 13-point difference between the HERS index and the energy rating index. So this isn't something that's an isolated thing. This is a constant thing. Ryan Mears is absolutely right. They will always be out of sync to some degree. My point is the degree is often more than people think it is. And that's can be a real problem, again, if code officials accept the HERS index as an equivalent to the energy rating index, because most code officials don't understand what the HERS index is. I'm confident in that because most energy raters don't understand how the HERS index gets calculated. There's Philip Ferry, who's the architect behind the HERS index, and I sat down one time and made a list of who knows how this thing works. And we could count them on all of our hands, all fingers on our hands. That's how many. There's probably more now, but most people just assume that it's an energy efficiency thing that governs based on energy consumption, energy use, lower utility bills, percentage reduction, and it's not a one-to-one comparison at all.
I'll never forget the look on Philip's face. I was sitting next to him at the RESNET conference when the board of directors meeting, when Jeremy Williams with DOE gave a synopsis of our HERS variability study to the board at RESNET. The look on his face, I wish I could remember what it was he said, but he was not happy. I'll put it that way.
Yeah, there were a lot of board members were not happy, and they started saying, well, the study was invalid. They actually commissioned another study to study that study to prove that study was invalid. And and then the technical committee side, we're about the science and we're about math, and math is not science. Math is fact. Science is a lot of guessing.
Right.
And you're always trying to prove your hypothesis in science, not confirm it, so that you can reduce your confirmation bias. And so we actually had a guy that was on one of our subcommittees. Every time we would go have the RESNET conference, he'd put together a group of raters randomly. He would just, they'd volunteer and they'd go out and rate a house. And then he would collect the data on all the ratings that they did on those houses. And then he'd do these comparisons. And the numbers were all over the place. And so the variation is there. The variation between the HERS index and the energy rating index is caused by the information on this table. And again, this just goes to show that there's a lot of differences in the way the standard that is referenced, the 2015 ERI, there was no reference standard for it. And like I said, if you read that language that's in the code, the HERS index does not comply with that language. And, and that was a real problem, because everybody was running around saying, well, the HERS index is basically the 2015 ERI is the HERS index. And I read that language and was like, yeah, when hell freezes over.
Right. I had the Pacific Northwest National Lab tell me the other day in an email that ResCheck calculates per R405, it does the performance calculations. But then when you go and read the code, what has to be included in the performance calculations? And then, well, how does ResNet ResCheck do code compliance performance calculations when it doesn't take into account HVAC? I mean, that doesn't.
Yeah.
How that yeah. I can read. I'm sorry. I know you're PNNL, and I know you're claiming that it's code compliant, but I can tell you that it's not.
Yeah, and and it's this kind of confusion that gets out there, and a lot of times we have to deal with this. my clients, the energy raters, they have to deal with it in a lot of jurisdictions, because their competitors are claiming one thing. I mean, we just literally just last night, we had a res check email to us where in in Fredericksburg, Texas, there's a person submitted a res check claiming R13 continuous insulation on the walls and R38 continuous insulation on the attic floor.
Oops.
And we're going, there's no way in hell that's even possible. And to their credit, the city of Fredericksburg, the code officials were kicking it back, saying this isn't good enough. This is not it. This is not it. And we got copied into this email exchange, and the code officials were holding the line saying this does not comply, this does not comply, this does not comply. And the energy raters saying, yes, it does. You know, I'm an energy rater. Well, it turns out the guy that's doing it is not an energy rater. We looked him up in the system, and he hasn't been an energy rater since 2017. But he's out there pumping out res checks that claim all kinds of wild stuff.
Yeah.
And this is, you know, it just contributes to the confusion in the marketplace. You know, what the hell are code officials supposed to do? You know, this is not their area of expertise, and they're relying on energy raters for that expertise, and yet they're not getting it. Half the time they're getting God knows what, and half the time they're getting good advice. How do you know it's good advice? You know?
Yeah, and adding all this confusion, I mean, to me, it just degrades the validity of the energy code generally, which to me is almost the greatest ill that is afforded by this confusion and this. I mean, frankly, to me, it's way too complicated, especially the commercial chapters. But I think if it was, well, I don't know. I got lots of different ways to think about it, but in my world in which I travel, the energy efficiency world, you know, all of the folks, oh, it's got to be performance. It's got to be performance. And just my possibly pea brain mind, I don't know what it is, but I'm just thinking, well, if we had just some minimum prescriptive requirements, wouldn't that just be a lot easier for everybody?
Yeah. And so back when I built houses in Tennessee, I looked at the prescriptive path. It was like, this is the worst thing that I can legally get away with building. I can do better. And that's just the way I always looked at the code. The code is not the ceiling, it's the floor. If you build worse than that, you know, you deserve to be put under the slab. And so I worked with my code officials when I was building. You know, I'd go down and I'd have meetings with the chief building official and all the inspectors saying, you know, here's the stuff that I want to do. And it's all beyond code, but I want to make sure that your interpretation and my interpretation are the same. So that's what I did. And my houses, by the way, were awesome because the code officials were able to help me figure out where I could make improvements, you know, and which trades I needed to make improvements with. And in addition to that, they also helped me figure out that, you know, there's a better way to build. And so they became one of the best resources I had as a home builder. And in fact, I had a committee, a construction committee that I had to report to. I was building Habitat for Humanity homes, my last construction job. And I got the chief building official to be on the committee for me. And so he would give, you know, he was there to put in, you know, from the code perspective, when we're doing advanced things, beyond code things, whether we should or not. And that input was valuable, super valuable. And I always just looked at the prescriptive path and said, okay, how do I beat that? And as long as I did better, I was awesome. And then things get really confusing when you start plugging in software tools that does who knows what. And you've got different people putting in different inputs that produce who knows what. And now all of a sudden the code officials can get really confusing very fast.
Oh, real fast. I tell, when I'm giving builders a conversation, presentation, the total UA path. I'll tell builders, oh, I can make your home comply in Dallas, Fort Worth, climate zone 3, no problem with you find some old R11 bats for sound, we can put those in the wall, and we can just do like a R13 cavity bat in the ceiling, as long as 80% of your walls are 20% better than code windows, you'll comply total UA. And they're looking at you like, what? That house is going to be an energy pig. Yeah, but look at the way the total UA calculation works.
Yeah. And that's, you know, and it's crazy, you know, from my end. And you know, you guys got to understand, I've been up to my eyeballs in this for, you know, 20 years. And I look at it and I go, you know, for me to figure out you know, what's the best way to build a house? How do we get energy efficiency baked into the system the easiest way, the least amount of confusion? Let's make it easy for the code officials. Let's make it easy for, you know, for everybody. Let's make it easy for the builders. You know, following grandma's recipe, if you follow grandma's recipe every single time, you're going to get grandma's cookies. And that's basically what the prescriptive path in the code is. And if you beat that, if you can do something better than that, then you'll have something better than grandma's cookies. What an awesome deal. But when you start deviating from that and you start getting into this, and you know, I had one builder client one time, it cost him more in my time alone and in the extra things in the time that he wasted trying to figure out how he could build a house for cheaper. It cost more money just in my time and the advice that I was having to give him, which it always ended up saying, no, you can't do that. You know, don't do that. Don't do that. Don't do that. It's just insane. And of course, there's the work that the energy raters do, absolutely important. You know, having them out there, they're trained in building science. They're trained to do the blower door test. They're trained to do the duct leakage test. They're trained to do ventilation testing. They're trained to look at the house as a system, to find the air leakage paths, to give advice to the trades, to fix this, correct this. The HVAC contractors, they're trained to work with all those trades to make this a smooth process. The work that they do is super valuable. The test results, the performance tests that are required, super valuable in the pursuit of energy efficiency. Where things start to, you know, come apart is when we get into the software, when we get into the tech. And so this is, again, why does this happen? Well, this table right here explains exactly why we get these big differences in the energy rating index and the HERS index.
I see that mechanical ventilation. I see that in that data project we did, and when I'm doing field training and just across the board. And frankly, I go on a 15-minute mechanical ventilation rant, how it's broken the code and can't be fixed because it's based on occupant behavior. But when you look at the chart, anyway, long story short, just look at the variety in the column in your mechanical ventilation column. I mean, look at the differences there. I mean, it's just, and then in the 2021 energy code, you're going to, that is, the HERS raters will be happy to be working in jurisdictions that move to the 2021, because while you're there doing duct and blower door, you will need to test the mechanical ventilation as well.
Yeah, and most of them are testing it now anyway, but now they can justify getting paid for testing it, because in the HERS index system, we have to test the mechanical ventilation, because that's one of the 250 data points that gets plugged into the software. And that's kind of the wacky thing. And again, there's a whole presentation to be done on how ventilation actually gets calculated, because a lot of people get confused by that as well, particularly when it comes to the software inputs. So there's another future presentation for you. So this is what we're faced with. You know, why do we have these differences? Well, they're all calculating different things. And if you calculate different things differently, you're going to end up with a different result. That's guaranteed. And this is the big result. The HERS index does not comply with the code requirements for the energy rating index, period. There's no way. And it's a little bit troublesome when we have jurisdictions that mandate a certain HERS index number, And they say, well, as long as you hit this HERS index number, you're code compliant. And it becomes a little problematic because the HERS index doesn't have anything to do with the code other than they have a common standard that they're both based on, but they diverge. And so we get wildly different things. And, you know, it's a huge problem. It's a really huge problem for us. So I think I'm done, but I wanted to leave a lot of time for questions because I know there's probably going to be a lot of questions.
Well, I've got a few. So can you tell, so just energy load versus energy use differences. I'm just trying to get my head totally wrapped around that concept and what you mean and how energy load. Again, can you elaborate just generally energy load versus energy use differences?
Yeah, so energy loads are those elements in the building that are going to cause energy to be used, but do not themselves use energy. So if you think about it like this, the wall of the house doesn't actually use energy at all, but it can cause energy to be used because if that wall has less insulation or more insulation in it, it's going to change the difference. It's going to change the difference in the amount of heat that moves through that wall. Okay. Your HVAC system uses energy. So, you know, is it an energy load? No, but the demand for cooling in the house, like dependent on the thermostat settings and the weather outside, the demand for cooling in the house is a load because that's going to cause the HVAC system to use energy to drop the temperature. So these are the kinds of things that are the differences. And, you know, that's the real challenge is when every software vendor out there has a different set of things that they say are energy loads, then you end up with this big problem because none of them agree. So you end up with great divergences between software tools alone. And it also creates what I think is probably the bigger challenge, which is when builders are marketing their homes and they're using the HERS index as a thing saying, well, your home is going to use 50% less energy because you've got a HERS 50. That's not true. In spite of the fact that RESNET put out a video that says that, that's still not true.
Right. Yeah. But did you see the video? It did have some pretty good graphics. That doesn't make it true.
Yeah. I mean, you can have, I mean, they spent a lot of money on that. And the sad thing is they spent the money on that. And then they showed it to me and Philip. And we said, this is completely wrong. And they're like, yeah, but we've already spent the money on it. I was like, okay, but you spent the money on something that's wrong. Don't put it out there. And it's just, you know, ridiculous. The kinds of things that we see. So that's, you know, RESNET is contributing to this kind of confusion in the marketplace when they send those messages out there and they put those videos out there that builders are relying on, you know, and on the marketing side. So, you know, I always have this big fear of, you know, one of these days that the wheels are going to come off of that bus and a bunch of people are going to, you know, go together and sue a major production builder because of their marketing claims, which are based on stuff that's not true. And I probably shouldn't have said that, but I don't care. It's the truth. That is a huge concern of mine. And that's when I go to builders and I talk to builders, I say, listen, don't market your homes that way. Don't do that. You're in trouble.
Yeah, we don't see, in Texas, we don't see too many. And for code compliance, we see close to zero homes submitting ERI pathway for compliance. Not literally, no exaggeration, 99 out of 100 homes in climate zone 3 are R405. I mean, they're not R406. So they're using the performance path. Yes, they have a rim rate HERS. They might have a HERS report from Ecotrope or rim rate, but the compliance path chosen for permit is almost always R405. especially in climate zone 3. Climate zone 2, you actually do have most builders using total UA and res check, but there's
Yeah.
still a handful. I had Top Build at my presentation in Victoria on Tuesday, and I asked Top Build, who does a lot of homes in Texas, how many they anticipate submitting using the ERI path for permit, and it was 0. How many did you submit last year using the ERI path for permit? 0. It's all 405. And that kind of lends into Andrew's question. And I thought rim rate still had market share. I know 2 years ago, rim rate had 90 plus for a lot of the market share. Andrew asked, is Ecotrope the main HERS rating software used? Did you say that it took the lead over rim rate?
Yeah, they took a big lead over rim rate. Rim rate ran into some pretty serious technical problems because they had to update their calculation engine. They had to switch to an hourly calculation engine from their proprietary system, which was built on software from the 1980s. So, which had been patched, and then the patches got patched over the years. Yeah. And when they had to basically take it down to the foundation and work with this new calculation engine, they ran into real serious troubles, and they lost a lot of market share because the numbers that were being spit out were just ridiculous, and their development time to get it to be compliant with ANSI 301 requirements for an hourly calculation simulation engine, it just really it hurt them a lot.
Yeah, wow.
And
yeah,
and
I'd heard, and I think they were probably focusing a lot of their time on that, and I'd heard general complaints about customer service from their raters and software purchasers as well. Joseph wants to know if you can come with me to my field training in McAllen next week. I can't put him on the payroll, Joseph. He's doing this for free. I don't think he's going to drive with me to McAllen and not need some money.
Well,
Brett, you are welcome to ride with me to McAllen on Tuesday if you'd like. Robert says, due to increased shortages in radiant barrier specifically, which I am happy to announce that supposedly they have caught up to the radiant barrier shortages. So those have gone away, is in my understanding, or will be going away in the coming days and or week. It says the energy compliance path being used calls for the radiant barrier. What can a builder do? Substitution. I'll take a shot at it first and then turn it over to Brett. Well, that radiant barrier on R405 is just saving a little bit of energy, just like everything else in R405. So going from R38 to R42 in the attic, I'm guessing would more than offset the radiant barrier. But a little bit better windows, any other increase in building thermal envelope or energy HVAC use items with R405, any increase in the building thermal envelope or decrease in the energy use of HVAC would help offset that radiant barrier. Do you have any other? I know the city of Austin, you're not offsetting it. City of Austin has amended their energy code to require radiant barrier in single family houses. And if you've ever been in an attic in August, that one, you can go in a house with a radiant barrier and they go in a house next door without, you will be sweating significantly more in the attic without radiant barrier. So Brett, I'd like for you to answer the question about substitutions for radiant barrier. And then I'd also just like to get your thoughts, if you don't mind, just radiant barrier in general, and your thoughts on that.
You're trying to get me in trouble with the radiant barrier guys.
No, because I have a feeling there's a truth under there that I'm not aware of.
So one of the things that we found, for example, I think the city of San Antonio has recently gotten this thing about the radiant barrier shortages, that you can substitute the shiny paint for it as long as it meets certain requirements. And it's one of the big challenges that we have, is there's so many myths about radiant barriers and how they work. For example, they do not reflect heat at all. That's not what they do. I've seen so many builders put radiant barrier sheathing underneath the siding on the walls of the house. I'm thinking, that was a waste of money, and now your vinyl siding is going to melt. But radiant barriers got a lot of myths and misconceptions about them. They work really, really well when they're applied correctly, but they also have a slight side effect of increasing dramatically the temperature of the lumber that it touches. So the top cords of all your trusses and all your rafters, that temperature of the wood goes up quite a bit. And in some cases, we've actually, on really, really hot days, when you're in triple digits, I've measured the temperature of rafters that have on houses that have radiant barrier on the roof deck, on the underside of the roof deck. And because the radiant barrier is collecting all that heat, and it's heat greedy, and it's holding that heat, it releases it to anything that it touches, but it doesn't release it to the things that it sees. The amount of heat that it releases to things that it sees is greatly reduced. But everything it touches, it conducts heat like a son of a gun. So what we see is in those rafters that radiant barrier is sitting on, they tend to be a lot hotter. And in fact, they can reach the slow degradation temperature caused by heat, which basically means that over a long period of time, that could potentially lead to a failure in the lumber. And I brought that up years ago when Louisiana Pacific first brought out Tech Shield. I brought that up to one of their guys and said, you guys looking at this? And they said, no, why would we do that? I was like, well, much like putting plastic in your walls, this may be a problem that comes and bites us in the ass in 30 years. But it's just something that I look at and go, as a researcher, building science guy, I look at it and go, yeah, that might be something that we should be paying attention to.
Right. Especially applying polyurethane spray foam. I mean, a customer changes his mind. You wouldn't put radiant barrier on a house with foam typically, but if you're doing you're midway through a house and a customer buys it and a customer wants foam and you've already got the radiant barrier roof deck up, well, as a builder, you're not going to rip that off. You're just going to foam the radiant barrier.
Yeah, and there's so many problems with that. There was a builder that was having that issue. They were building down along the coast, and they were having that issue, and they vented the attic and everything else, and then the customer says spray foam, so they spray foamed everything, and that house had it started raining in the attic because the HVAC guy did something really silly. So it was pouring down rain. It was literally water droplets. It's like misting inside the attic, and then there was liquid water coming out of the walls after they put drywall up and turned the HVAC system on. And, that's a problem. And because a lot of times builders don't stop and think about the consequences of substitutions and things like that, it gets to be a real challenge. And that's where energy raters can be super useful in helping builders sort that out and helping code officials sort that out, like which materials should work. You can't rely on architects anymore. We find that a lot of architects, the amount of education that they get in building science is mostly, it's a couple of hours. And a lot of them fail to understand that, that connection between the materials that they specify and the performance of the homes. And one thing that we did learn a long time ago is power attic vents are the worst thing that you could put in a house because they cool the attic down by creating a negative pressure zone directly above the house, which causes conditioned air to leave the house and get sucked up through the penetrations in the attic floor and into the attic. And then on top of that, you're paying money to run the vent. And so it causes the HVAC system to run longer, using even more energy to keep the house comfortable. And then you're throwing conditioned air up into the attic space to cool the attic down, using another fan up there that's even using more energy. So one of the sneaky things, dirty tricks that we used to do a long time ago, is we just cut the wires on them.
What would you think about if your ceiling was sealed really well? You did a really good job sealing all the penetrations in your ceiling, and not necessarily a power vent, but like a whirlybird type roof vent. If you had, then the other caveat, plenty of venting at the soffit. You had like a good continuous soffit vent with plenty of net effective opening, and then you had whirlybirds in the top. What would you think about that?
So we've actually looked at this a lot. And in research done in Florida on actual houses, not theoretical computer simulation models, but actual houses, research that was been done in Texas. We look at attic ventilation, and one of the challenges is the code ventilation requirements, the minimum code, is the worst amount of ventilation that you can provide. You have to provide a lot more. You have to ventilate the hell out of that thing. And the best way to ventilate that is to have 1/3 of your openings in the lower third of the roof, and the 2/3 of the openings in the upper 1/3 of the roof. So you've got more outlet than you have inlet. Mm-hmm. And the other challenge that we've run into is people have gotten away from proper ridge vents. The high profile ones, they think they're ugly, so they go for these low profile vents. But the low profile vents only work partly. They don't work all the time, and they don't work on both sides all the time. But if you have one of the high profile attic vents, they've got that lip that runs on the outside edge of it. And that lip actually, when the wind blows, it creates a Bernoulli effect. And so it sucks air out of the attic on both sides as it blows over that ridge vent. And so we actually found that a good deal was full soffit venting and a good ridge vent, and then put in some turtlebacks or turbines to help. None of them requiring any power at all.
You would be okay with a turbine then?
Oh yeah.
Yeah, that's kind of that's what I advised. A coworker of mine was getting a new roof, and she was trying to determine between, just static versus whirlybird versus power vents. Oh, do I spend the money on power vents? And I told her I wouldn't power vent my attic. Heck no. I would make sure and have a good continuous soffit vent. And I'm one of the few code officials I know that has written a bunch of red tags for underventilated attics. But man, at least in the jurisdictions I've worked, I see it all the time. Or another pet peeve of mine that I've written a bunch of red tags about, and I'd advise all the code officials on this call to do it as well. If on a fully foamed house, well, if there's above the garage, typically they'll extend the wall right there at above the garage, and they'll foam encapsulate everything that's not above the garage. Well, that attic area above the garage needs to be ventilated. Or a lot of times, depending on, a big custom house or something that's foam, you might have little, and it might only be, 40 square feet. It might not be very big, but I would always make them ventilated. I didn't feel like I wanted any stale, static, moisture collecting, unbreathable attic space anywhere in a home.
Yeah, and another place that a lot of people forget about are porch roofs. Because the problem with porch roofs is you end up with that heat buildup in the attic. If the porch roof isn't vented, that attic over the porch is not vented, then that heat buildup transfers through the wall into the house.
Into the house.
And we often find that that's a poorly insulated wall because they forgot to sheathe the exterior before they framed the porch roof up to it, and all kinds of other issues. Mm-hmm. And we shoot infrared and it lights up like a Christmas tree. Like, holy cow, what's going on here? And, some of the other challenges that we've seen is, and this is funny because I'm looking out my library window right now at the suspect house in question. One of my neighbors had their house re-roofed, and they didn't have any ridge vents on the house to begin with. So all they had was soffit vents and just a few. They didn't have enough attic outlets, turtlebacks or turbines. And so the roofer comes in, and I watched them do it. They ran felt paper. They ripped everything down to the deck, and they ran their felt paper, and they covered the peak of all the ridges with felt paper and the shingles, and then they nailed on the attic, the ridge vent over the top of that. So it looks like the house has a ridge vent, but it doesn't.
Oh, no.
So unless you go up into the attic and look up there specifically for that, you're not going to see it. It looks like it's got this massive amount of attic venting, but It doesn't. It's completely covered up. So, so how many code officials, are going to be climbing up into the attic spaces and looking at that? Particularly like I heard from a code official in Las Vegas, they said that builders won't even provide a ladder for them to get up into the attic and look at things because the builder doesn't want the liability if the code official slips off the ladder. And so they're relying on the builders to take photographs of things and send it to them.
Oh, wow. Yeah, that's
And I'm
crazy.
like, what the heck? How, wow. Cause I know what can happen. I've seen it, and then, there's, I just looked at the chat. There's one question from Robert on best energy compliance pathway, prescriptive, UA, performance, or ERI. So we've talked about challenges with the energy rating index and the HERS index. And Jason talked about the UA calculation, the total UA calculation. The performance path has another interesting challenge, Jason, and I don't know if you're aware of it, but there is no organization that vets whether or not the performance path calculation software tools actually do what they're supposed to do. RESNET used to do that.
Yeah.
We had a publication out and we would run these tests and then we'd say, yep, this software complies with the requirements. But at the 2015 spring board meeting, I pointed out that RESNET had authorized a software tool for the 2015 code when we didn't have a publication that had been updated to accommodate the 2015 code. And I brought that up in a board meeting, and that unleashed all kinds of havoc. And RESNET's decision was to get out of vetting code compliant software. So there is absolutely no organization that vets whether or not a code compliance software tool for the performance path is actually doing the calculations correctly.
Well,
and so,
yeah, ResCheck doesn't, in my opinion, but even though the lab that creates it just told me that it does, but you read the code, read 405 as a code official and read the calculations that are supposed to be included in that. And
ResCheck absolutely does not.
No,
they neglect HVAC entirely.
And so, and it clearly says, and look in section R405, you have to consider that energy use.
Yeah. I tried to get the ICC to take on, because it really should fall under the ICC, to take on approving code compliant software. One, it'd be a revenue stream for them, but two, that's totally in their bailiwick to do that.
Absolutely. And they could charge for it. I mean, why couldn't they charge for it?
Oh, they would.
Yeah.
You charge it, they could, it's a revenue stream for them.
Yearly fee.
But there's a lot, I mean, those performance calculations, there's a lot behind that. You look at the table, here's what the reference design home's supposed to have, and here's what, gets put in the, the as-built is going to be whatever, as proposed. Mm-hmm. But, there's a lot behind those calculations that can be fiddled with to get answers that may or may not be correct. Which is why there needs to be an independent organization that looks at that stuff, because it's incredibly complicated. The software is incredibly complicated. I calculated a HERS index by hand one time, and I was writing with a pencil, and writing small. I filled up one of those entire 3M notepads before I finally got to my answer. And I took pictures of it and sent it to Philip Ferry to ask if I did the calculations correctly, and he said I did. And that's when I discovered that REMRate had a serious calculation problem, because I had a guy, a PhD mechanical engineer I've mentioned before, he actually created a spreadsheet that calculated the HERS index, and his number was different than REMRate's number. And then I did it by hand, and my number was 1 digit off from his number. So I sent it to Philip Ferry, and he said, we were right. And I was like, well, Philip, we got a problem with REMRate because they're off by like 5 numbers.
Yeah.
There's a big difference between what we got and what they got.
Yeah.
And
That's a problem.
And that was just,
And that's why I mean there's no answer to that question, Robert, because you can build a better house by any of those four paths you listed. However, in my opinion at least, if I at least get the minimum prescriptive requirements, then I at least don't have concern about any fuzzy math in the calculations on UA performance or ERI. And in a perfect example on the total UA calculation, to me, is especially egregious when you think about the intent of the energy code is to save energy. And as long as you bump up your allotted U value, your baseline U value, by putting it, like I said, I mean, we all know windows are less efficient than walls, right? I mean, they are making some really good high dollar triple glazed windows these days that are close. But typically in our market in climate zone 2 and 3, we have 0.21 solar heat gain, 0.32 U, something like that is about an average. That window doesn't perform as well as even just an R13 cavity wall. And so with the total UA or any of those other paths, if you're trading off, typically your windows are your weakest, right? I mean, but where performance in ERI, I would say those would be better. Those would be better if you're getting credit for putting your mechanicals in conditioned space, which obviously is one of the dumbest things we do in Texas, is put our piece of equipment responsible for cooling the air in our 140-degree attic. So I just don't think there's really an answer there, but straight prescriptive to where you're not trading off those building thermal envelope requirements. If you do straight prescriptive and you get your mechanicals in conditioned space and you're just using the 2012, 15, or 18 IECC, I think I'd be pretty happy with that. Well, if you, this is a question, good question for you, Brett. You're building your own house and you today, in today's market, you're going to build your own house from scratch, price considered, you know, obviously rammed earth and passive house and solar and geothermal and, you know, solar hot water. Oh yeah, that's all great if we've got $1 kajillion. But if we are working from a budget, could you briefly kind of detail your floor, wall, ceiling, mechanical, and insulation plan?
yeah, because so what I do is I look at, you know, like the basic, you know, the code prescriptive path. That's a good place to start. And I like using the software tools to show me basically the relative performance increases I could get from different strategies. You know, so one of the things that I found was, and I'm a really big fan of this, in spite of the fact that, you know, I'm a fourth generation home builder and love working with wood. I'd build my house out of concrete. I'd build my house out of autoclaved aerated concrete. So I'd start off, I'd have a basement because that's going to act as a heat sink. And plus it'd give me a nice place to store all this excessive amount of wine that I have at my house. Mm-hmm. And I would look at that. And so I would have a slab floor in the basement, obviously with the sump pump and everything else. And I would have some exterior insulation in the form of fiberglass drain mats or something like that on the exterior of my basement, concrete walls, come up, frame floor, and I would put my HVAC system down in the basement. And then I would have aerated autoclave concrete walls, and I would do spray foam roof deck, or I would use SIP panels for a roof deck. And that's pretty straightforward, pretty easy. Mechanicals becomes the only challenge. And I'm a big fan of the ductless mini splits. They allow the occupant to control the comfort level in that room. You don't have to worry about duct leakage, which is a huge problem. And the HVAC contractors, their installers, every single system that I look at, well, I won't say every single, 99.9% of the systems that I look at, they're not installed correctly. They're not installed according to what the code reference standards require for installation of ducts. And you know, it's a horrible way to try to condition a house. When you're, using these flexible tubes, they're not put together correctly to begin with. And you end up with comfort problems when you could just directly condition the space that you're trying to directly condition. And so that would eliminate the duct leakage, and plus there's super high efficiency. And you can connect multiple heads to a single outdoor condensing unit, which is also awesome. They get variable refrigerant flows. And when I look at that particular collection of components, the cost on that is within $5,000 to $10,000 for the house plan that I have sitting on my shelf, versus doing what we do traditionally with a lot less headaches.
My concern, and I'm actually Hebel. I've got a Hebel rep that I'm trying to get to do some things with me and to meet me at some trainings down in the valley and put on a webinar, because that aerated autoclave concrete's just some phenomenal stuff. I'm just wondering, my concern with that, or SIPs, or ICF, is just finding the contractors that know how to work with it.
Well, that's the beautiful thing with the Hebel block, or the AAC. Hebel's the brand. It's like Kleenex. It's a brand name for it. That's the beauty of it, is it's lightweight blocks, and they make these, they have these little cranes that you can rent to move the bigger blocks up. You don't have to be an expert in it. You can use woodworking tools on it. Projects that I worked with in Chattanooga that used this, they would basically, the crew went out and they bought an electric chainsaw, and at the end of the job, they chucked it in the dumpster. And use woodworking tools on it. You don't have to have a ton of skilled labor at all on it. And, it's like, holy cow. And it eliminates so many problems that, the material costs slightly more, but the labor savings and the other material savings, it's almost a wash, because you don't have to have skilled labor to do it. Now, if you go try to find yourself a masonry contractor and say, hey, I want to hire you to do my Hebel block installation, he's going to charge you an arm and a leg, because they'd never do it.
Yeah.
And so it's something new, and it's like, it's not that hard. About the first 3 hours on the job, you can train, high school students to put it together, and it'll go, and it'll work, and it'll stand up, just because the nature of the beast. I mean, that stuff was invented in 1922 by a Swedish physicist who was looking for a way to find building materials that could be available on every inhabited continent, that would work in the hot, work in the cold, work in the humid, work in the dry. And he invented that Hebel block system, the aerated autoclave concrete system. And it works. It works in Thailand. It works in the Philippines. It works in, it works in Siberia. It works everywhere it's used. It doesn't have to cost more money to do it. It's just, it's something different. Because it's different, people say, well, it's going to cost more.
Yeah.
But, I could, give me, 6 high school kids and 3 hours, and I could teach them how to put that house together.
Yeah.
In terms of the structure side, and it would work.
That we're still stick framing 999 out of 1,000 homes. It just is,
which is
so
crazy, because Seguin, Texas, where I live, back in the 1850s, was known for concrete construction, and we still have, there's like 30 concrete houses that were built back then that are still being lived in. And the only time we started, in Seguin, they started framing with wood was after the trains showed up, the railroad showed up, so that we could get lumber out here that was usable for framing, and so that's just kind of nuts that we're still building out of wood. And I love wood. I was brought up in the building trades as a carpenter, building houses, and I love wood. Don't get me wrong, but good Lord, there's a time and a place, and it's just, its time is past. We need to be looking at materials that can last 200 or 300 years, and not just 30 or 40 before you need a major renovation. Oh. And Garrett was pointing out that there's a guy, he moved on from YouthWorks in Austin, but they were building out of a version of aerated autoclave concrete with at-risk youth, and they were basically baking the blocks in the sun, and it was like amazing.
I mean, I think Richard Morgan was part of that Youth Works in Austin, if I'm not mistaken, my predecessor, so to speak.
Yeah,
it's crazy. I don't get it. I mean, but it just, I mean, were you to guess 20 years from now in Texas, what percentage of homes are going to be stick frame?
99.99%.
I couldn't agree more. And
you know, that's what they do.
That's what they do. Yeah, I don't get it.
And it's a shame because there's so many other materials that are out there. I was hoping that with the lumber shortage that we'd see builders shifting to you know, I don't want to say alternative building materials because they're not alternative, they're just different building materials, and it didn't happen. And I thought, you know, and then I'm looking at putting an addition on my house, and I'm looking at aerated autoclave concrete. And so we reached out to one of the manufacturers, one of the distributors in San Antonio, and you know, getting them to return calls is like pulling hen's teeth. It's like, don't you want to sell something? You know? But apparently, at my yoga class this morning, the coach was having the same issues with other things. Apparently, that's a common thing among businesses now, is they don't return your phone calls when you want to sell things.
Everybody, when it comes to construction materials, everybody's already got it, you know. I mean, they don't care if they got your business because there's 19 other people. I was shocked I built a cantina bar again over the pandemic. I've been building a cantina bar, and just over oh gosh, it's been about 10 months now. I mean, that 10-foot 2x4 has gone from $6 to $8 to $10. And it's just paying $1 a linear foot. I remember working in a lumber yard in high school, and we had all of our lumber calculated by the board foot. Oh, it's a 2x6, okay, 0.5, and just doing those calculations. And I'm just thinking about how in the world did a 10-foot 2x4 go from $6 to $8 to $10 in 10 months? But it has.
Yeah. Well, we actually did some analysis on why that happened for one of our clients, and it's just crazy. Like,
what was the analysis? Well, did you come to any conclusions?
Yeah, so it was like the perfect storm that caused these challenges. You know, we had wildfires. We got in a tariff war with Canada where we misapplied we misapplied some tariffs, and so there's this big tariff war that we ended up with Canada. So we ended up not, you know, paying a lot more for Canadian lumber and all this other stuff, and wildfires. And then one of the big impacts that, you know, the wildfires weren't necessarily destroying the lumber, but it was disrupting the transportation because of the railroad systems that were threatened by the wildfires up in the Pacific Northwest and places like that. And then, you know, and then there was the OSB challenge, which was, there's been a huge consolidation for efficiency. There's been a whole bunch of acquisitions made, and so they've shut down all these independent, you know, the smaller OSB plants that they'd acquire, and they'd consolidate their operations in a big place, and then all of a sudden you get COVID, and that place has to shut down, and now they've got nothing. And, you know, so their stockpile dwindles. And, you know, it's just, as one of my clients is a economist, he says it's not the law of supply and demand, it's the law of demand and supply.
Right.
And, you know, so that hits, prices go up. And
well, that gives me hope for things like aerated autoclave concrete. I mean, Charles, one of our ambassadors, chimed in from Oklahoma. He says he's getting 12-foot 2x6s steel cheaper than spruce pine fir.
Yeah. You know, I worked on a project in Chattanooga that was a custom home built for the mechanical engineer that designed the ventilation system for the channel between England and France. and Alan insisted on his house being built out of steel because he wanted it steel and brick. That's the whole thing, steel, brick, and concrete, the whole thing. Even his stair risers were fabricated out of steel because he wanted the house to last 300 years. And I looked at him and said, Alan, you're not going to last 300 years. What do you care? And he goes, it's my legacy. And the reason he called me in was because there was a guy told him that this his house wrap had an R value of 10. And so he just needed to put that house wrap on directly over the steel studs and he was good to go. He could brick up right over that and he would be super energy efficient. And when he called me, it was back when I answered the phone when I was driving. I almost put my car in the ditch when he said that. I was like, what the, an R value of 10 for house wrap? Whoa, hold on. Let me get back on the road and I'll come visit you. We'll have a discussion. And, it's a lot of times we see this in steel structures down here, the barn dominiums and things like that, they're required to have continuous insulation.
Yeah.
And we rarely see continuous insulation on them. And it's like, well, you got to go to a different table in the code and look at that. Steel framing, continuous. That's what the plus means.
Well, and just, you got to understand thermal, the thermal bridging of steel versus wood, it just cavity insulation's not going to get it done. I'm curious.
The worst one.
Go ahead.
We had one that said they had, they did it all steel, no continuous insulation, but they use spray foam. They said, well, the spray foam stops that. And I said, you didn't cover the steel studs with spray foam. You insulated between them with spray foam, but you've got these, super conductive super highways for heat transfer. And you're in Texas, dude. This is not going to work. Wow. And, he was wondering why his HVAC system was always running. I was like, well, here's your sign.
Because every 16 inches around the entire perimeter of your house, you have massive heat transfer coming from outside to in. What do you think about
red sticks?
What do you think about ICC's decision to move the IECC to a standard?
Having spent, nearly 10 years of my life working in standards development in, ANSI standards, I'm a fan of that.
Me too.
Because
we're one of the few. I'm telling you, people looked at me like I had three eyes when I'm on these calls with the state energy offices or Responsible Energy Codes Alliance or any of these other monthly calls, the other RIOs. We do monthly calls and I'm the representative for SPEAR. And I'm the only one every single call saying, I don't think this is the end of the world, y'all. And in fact, I think with the 2021 as the baseline, moving to a standard going forward might actually make the code more workable and better. And everybody's just looking at me like I got three eyes.
Yeah, it actually will, because under the ANSI standards development requirements that the ICC is going to be following, they're required to have balanced committees so that no one group has more influence than another, and the distribution, of who those users, who those people are, is pretty well regulated, and it gets reviewed by ANSI itself. They have to review all of these things. So there's this oversight process to make sure that you don't get overrepresentation from code officials, you don't get overrepresentation from builders, you don't get overrepresentation from manufacturers, you don't, whereas like right now, I saw this in the 2015 final action hearings in Atlantic City, the room is empty. And then all of a sudden a busload of people show up just to vote, and then they leave to go to the casinos in Atlantic City. And I'm thinking, well, how's this happening? What the heck is going on here? They're busing people in for votes. And I realized that we had the best code that money could buy. And it was just ridiculous. And it takes it more to an honest to God, well-designed process to develop a standard and a code, not a system where the loudest voice gets. I watched an attorney who works for a glass manufacturer argue that you could put 2 inches of foam board under stucco and it would work. And the stucco guys are saying, we don't have fasteners that'll hold the stucco up over 2 inches of foam. You know, we don't have the fasteners to do that. And, you know, but the glass attorney won. You know, he won the day.
Yeah.
And it's just, you know, it's just nuts. You know, when you go to a standards development process, a lot of that hoopla gets taken out, and it's going to be a big shock for a lot of people, you know, but the important thing is that if you participate in that, you get to make public comments on it, and they have to address the public comments.
Right. And that's what I was telling them. I was like, well, it's going to take the code development out of the code officials' hands. Like, no, it's not. The code officials can make comment. It's going to be a continual development, and they can make comments the entire time. And I was lucky enough to get ANSI on about a month ago and did a webinar for us, because frankly, I wasn't 100% well-versed in the ANSI standards development process, because code officials, we can't afford to actually buy the standards we're supposed to enforce. You're lucky if you're a building official to have a copy of the IRC. You don't have a copy of any of the standards that are referenced, not one single one of them. They're 70, 80, 90 bucks a piece. You're not buying them. So you really are, you're left with the paragraph in the code book that tells you to reference a 140-page standard that you can't afford. And so after an hour and a half, all about the ANSI standards process from ANSI, I wasn't worried about it before. I'm definitely not worried about it now.
Yeah, and addressing the public comments, you know, that's a very critical part of this, and required critical part of the standards process. And when we address the public comments, you know, the idea is that every voice that comments must be heard, and it has to be considered, right? So we have to actually stop and think. It's like, we just can't say, you know, duly noted, you know, there's our response, duly noted. We have to stop and think, like, well, hold on, let's dig into this. You know, they're taking the time to write this comment. We need to explore this comment. And I spent an extraordinary amount of time. You know, when I was doing the chair of the ANSI Standards Development Committee for RESNET, the technical standards, I volunteered about 500 hours a year. And a good chunk of that was literally going through, looking at the comments and composing responses that were, you know, draft responses that then we'd submit to the committee for the committee to review and the committee to consider. And then the committee would have to vote on these responses. And, you know, it led to a lot of discussions, and we often changed what we'd originally thought because, you know, somebody pointed out something that we hadn't thought about. And it's like, well, that's really important. We need to address this. And you know, and that's what caused the big delay and prevented us from hitting the deadline for producing it in time to get referenced by the 2015 IRC. Was we were spending a lot of time going through the public comments and not looking at them and saying duly noted. You know, that's like, that is so insulting.
Well, and
it doesn't classify the response.
No, and frankly, you diminish the integrity of the code when, I mean, if a code proposal is so bad it gets voted down 10-1 at the committee, and then you've got 50 of those that didn't even get started, but yet a pro-efficiency group, of which I obviously run in their circles, working for an energy efficiency nonprofit, Spear. And in fact, we gave a webinar on how to register your governmental member voting representatives. But then we link to a voting guide, which does not consider the code proposal itself. All it considers is, does it save energy? It doesn't matter if it's enforceable. It doesn't matter if these products exist yet. It doesn't, none of that. And so let's register, you know, hundreds of people in sustainability offices that don't administer construction codes. Let's register people in other areas of the municipality that really don't have anything to do with building science or construction. and get them to all vote for every single efficiency thing, no matter if it has no merit, you got voted out, but if it saves energy, let's vote for it all. In that even the pro-efficiency folks don't understand how that can diminish the integrity of the code. And then on the counter side, that was a great marketing, the Energy Efficiency Codes Coalition, Bill Fay, he did a great job. And I love visiting with Bill on the phone. Nice guy. I'd love to sit down and have a beer with him someday and just shoot the breeze. But the way that, in my opinion, him and his organization kind of hijacked that vote and had all those, the turnarounds. Well, what happens when in 3 years the NAHB decides, who's got a whole lot more money than that, they decide we're going to get a whole lots of folks registered that are going to vote by our voting guide. That's when the code gets rolled back. The code doesn't get rolled back when we start with the 2021 and then turn it over to a standards process. I mean, anyway, I beat that to death. And we got about 3 minutes. We got 3 minutes left. Here we go. In your opinion, should HERS raters be certifying homes to the IECC if they do not have their IECC certification through the IECC?
Hell no. I encourage all the HERS raters to get their IECC certification. And in fact, I encourage them to get the triple thing, get it. Get your IRC certification, simply because you're able to communicate better with code officials, and you have the ability to get a deeper understanding of what builders are up against, so that HERS raters don't do what a lot of energy advocacy groups say. Hey, well, just do this. Well, really? How are you going to execute that? The friggin' material isn't even available, or that's so costly. Or even something simple. I did an analysis once, when they were pushing for 100% high efficiency lighting. And I said, yeah, that saves energy in the South, but it costs you more energy up north, because the incidental heat given off by the inefficient lamps for lighting actually reduces your heating by more than the energy used by the lamps. So you end up consuming overall less energy. But what the hell do I know? I just look at physics and math, which is not science, it's fact.
And I loved your comment earlier about how science can change and be debatable, but guess what? Today, tomorrow, and for all eternity, 2 + 2 is going to be 4. Math is going to be math. That's just all there is to it.
Math is that.
Absolutely.
And that was, that was kind of the thing. So I think if energy raters are going to be certifying homes for the energy code, they need to be certified by the ICC, and RESNET came out with this joint, HERS rater ICC kind of thing. Mm-hmm. And the class was poorly put on, it was horrible. And there was like less than 50 raters in the country participated in that.
Oh, gosh.
And it's like, for goodness sakes, energy rater, RESNET needs to stay out of the, RESNET should stay out of the code business. That's the ICC's job. Yeah. And so, if you want to get the IECC certification, you can go to the ICC, and they've got training programs and certification programs. My company, we're a preferred education provider as well, and we're going to be putting together a preparation course for the energy code probably later this year. And these are just the things that you can actually go to the ICC's website, and you can find the preferred education providers. You can look at their content and go through the training programs and go take the test and get certified. The energy code is complex, but it's not overwhelming.
No. And as I interpret state law, I'm no lawyer, but the way that I read state law is you do have to have your ICC certification to be doing ICC energy code inspections. I would say that number one. And then number two, to know how to do a HERS rating doesn't cover the mandatory items in the energy code. I mean, a HERS rating is just that. It's not energy code compliance. It is the home efficient, you know, it's a HERS rating. It's different. Now, when you're submitting compliance paperwork for R405, you should have an inspection checklist and all that other stuff. But yeah, I agree with you completely. You need to get your ICC certification.
Yeah, and I agree with you. The language in the state law is pretty clear. If you're doing code inspections, you need to be code certified.
Yep.
And HERS raters are great for doing the performance tests and submitting that to the building official. You know, blower door, duct leakage. But once it sort of crosses outside of that, you're looking at the inspections and not testing of building assemblies and so forth, then, you know, it should be done. So we, you know, from my perspective, and I've been telling raters for probably 4 or 5 years. Actually, I started off talking about this in 2012. So it's been a lot longer than that. They need to get their code certifications. They need to do that because that's the only way that they're going to be able to continue to do business in the future.
Yeah, absolutely. Well, fantastic, Brett. We're 2 minutes over, so we'll go ahead and wrap it up here. Thanks so much for joining us, everyone. Yeah, and I'll see you in the Valley next week. Garrett did comment that he goes, man, he loves the Rio Grande Valley. He wants to come. That's a long drive. But I really can't. I mean, thank you so much, Brett. I'm going to hit you up in another few months, and I just think maybe 20 minutes of presentation of something and just talking building science like this for another 40. I mean, I just think kind of spitballing it and figuring it out as we go is fantastic. And just this kind of, I mean, there's going to be a handful of folks that left this thing that are going to look up Hebel blocks or autoclave concrete or some. I mean, we have to slow. It's incremental, folks. All of you on the webinar, it's incremental. We are not going to change this overnight. But if we can give our builders a good idea here or there, I mean, when I was building official in Granbury, the builders and I were partners. I mean, they took the good and bad. I can assure you I had a bad idea or two in there as well. But the good, you know, I mean, that perforated builder wrap's junk. Don't you dare use T-ply instead of sheathing, you know, and just some of those things. Well, the code says you can do it. Oh yeah, it does. But look what else the code says. I promise you, I'm going to spend 4 hours on your framing inspection if you switch to T-ply. So just be ready. So y'all all have that power, but be your builder's friends and realize y'all are on the team, and let's keep affecting incremental change. Brett, I'm giving you the last word, and then I'm shutting her down. Any parting words of wisdom?
Not really parting words of wisdom. I just really appreciate the fact that you guys took the time out of your busy day to pay attention to this, because, you know, once you start unraveling, you know, what causes what to happen, it starts to explain a lot of the challenges that you guys are facing and your builders are facing. And realize too that the energy raters, for the most part, are a great resource for code officials if they can start talking together instead of talking at each other.
Amen. Great way to end it. Thanks for joining us, everyone. Make sure to answer the course evaluation, and we'll see you on Tuesday for 2 hours of all things stucco. Have a great afternoon, Brett. Thanks again. Bye, everybody.
All right. Bye, Jason.